first speaker today is a special one. Mark is I have to read this, it's quite a title. A geospatial lead of solution architecture at Amazon Web Services. I think it's actually longer than that. He's out of Seattle. This is something he's been doing for over 8 years in various different capacities. He's previously worked on massively online open courses. He's worked on big data for Tier 1 universities. He's worked on security best practices for multiple industries. And he's been a technical guide to government mapping agencies. He's also the founder of Spatial Cloud, Alka Media, and he holds a master's degree from MIT. His resume is not the only thing that's impressive. What's also impressive about Mark is up until a week ago, he wasn't even planning to speak here when we lost one of our plenary speakers to a budget cut. I called Mark last Wednesday. We had, about a 45-minute conversation about current ongoings of geospatial technologies in Wisconsin, the direction that we're talking about going, and we covered a lot about what Amazon Web Services and other similar infrastructure is doing. It didn't take us long before we came up with a presentation that I thought everybody would enjoy. So without further ado, don't copy your data, share it. Mark?
So as Adam said, I have about 8 years in the cloud. The interesting thing for us here in Green Bay today is before I was in Seattle, I was in Green Bay working in my basement office. Oops, that is not good. Okay. That's not what I expected. I just have a Windows error recovery screen on my screen now. So maybe I need to talk a little bit longer. It's going to reboot. Okay. So before I moved to Seattle, I was here in Green Bay. I was the CTO of a startup, working out of my basement office. It was a business plan that we could not have raised funds for and executed on without the cloud. And today I'll try to speak really generically about the cloud. Obviously, I represent Amazon Web Services, but basically everything I will talk about today is it's about really the difference between what you can do, what you can hope to achieve in your on-prem data center, and how that's different in the cloud. And fundamentally, it's because in the cloud, you can do things like share resources a lot easier. I got a few pictures that hopefully will come up soon that speak to that. But there's one thing I'd like for you to kind of take away from today, my short talk today, is that we're all very accustomed working with data. I will show you things like geotiffs and shape files a little bit today, right? We've been doing that for a zillion years. As time progresses, if anything, the resolutions of those aerial and satellite images increase over time. It gets harder and harder to provision and just move that data around. It's a big data problem that many of us in this room have been working with for many years, right? So I've been operating using complete virtualized services for about 8 years now. Before that, I was making trips to data centers, and literally we had teams building our own server hardware because we had specialized requirements because we're mappers, right? You just couldn't go buy it for at least in the early days. All that stuff from Dell and HP was good, but folks in the GIS, especially if you're doing things like building backends for search engine portals and stuff, didn't necessarily satisfy your requirements. Okay, am I here? Thank goodness. Okay. I don't want to do this. Okay, sorry. So I'm going to have to actually kind of reboot here. I'm going to get my PowerPoint up first. There we go. I'm going to have to do this quick because I'm keeping an eye on you, Adam. We're going to run out of space here, our time here. So I'm downloading my PowerPoint. It took a second because I'm downloading it from our object store, which is on the web. Luckily, my Wi-Fi came right up. So I'm going to have to kind of restart a bunch of stuff that I had running. Can you see that? Okay, good. So the title is don't copy data, instead share it at scale, web scale. And it's a very simple idea, right? So, and this is something that I'm working on right now with a number of different customer groups. And probably the easiest way to kind of imagine this, many of you in this room are involved in this, right? So when we do things like acquire aerial data or LiDAR imagery, we typically, across the US and really in different other countries too, we do that as a consortium buy, right? We build partnerships, counties, cities get together and they'll do an RFP, and somebody will fly and fly that sensor. And we have a number of those vendors right in this room. Speaking to that, I went to the LiDAR session yesterday, which is great. And we do a group buy. But the odd thing is, even though the aircraft acquire this digital imagery and all this processing gets done, and it's a seamless mosaic of the region, at the end of the day, it gets shipped on a bunch of hard disks, via FedEx. And then everybody has an on-prem problem, right? And over time, this increases because the resolutions go up. So every time the resolution is doubled, there's 4 times the storage. We do this over and over again. So there's this, giant storage problem, giant compute problem. There's a bunch of processing involved, et cetera, et cetera. And so my basic premise is, we should be doing that. We should be collaborating around the data better. And and the cloud makes that 100 times easier to do, right? And this is just generically speaking. It can be on Google Object Store, Azure, I don't care. The model is that kind of data, especially that kind of big data. And the larger it gets, the heavier it gets, the higher the velocity it gets, the more it should be in a shared type resource. And I'll show that to you in real time in a demo in a second. So data copies are expensive. We have storage costs, we all know this, network costs, compute costs. And once you distribute the data, right, every time there's some, even some minor update to the data, let's say it's part of your QA cycle, right, all that data has to get shipped back out the door again, right? So you have this, even though you have maybe one contractor doing the job, they're distributing to all the participants in like an early stage, and then there's updates because of the QA cycle. It needs to get distributed all over again. Everybody's got to do this work all over again. And so you have storage, network costs, compute costs, cost to update those distributed copies. I'm sure I'm missing 5 others here, right? A lot of heavy lifting. So here's a picture that I borrowed from a Stanford library site. Stanford was one of my customers until just last year. And there's a whole site on their library system that speaks to a world of silos. And this is all I'm talking about, right? We live in a world of silos, even though we have cloud opportunities at hand. So I just want you to think about that. But there's 2 sides to this. One is, wouldn't it be nice, and what I'm speaking to here is, see where the data layer is on the bottom? We call these things, data, I think we call them data lakes, data oceans. So here's the actual website. Here's a very good kind of description of this problem. What you can't do in silos. And right here, it says access data from any other repositories. Use any other tools. You're bottlenecked by silos. And especially around things like state-level aerial image data sets, large LiDAR data sets that are meant to be shared. And they should be shared as some kind of clip and ship. I'm going to go get myself a little region. They should be shared, if not at the state level, at the national level. And you can do that now in the cloud. So going back here. So what makes cloud storage different? Number one, it's not siloed, as I said. You can provision in real time. You can provision dynamically granular access to it or not. What that means is that, so imagine you've got a pile of geotips because you just acquired a bunch of imagery. You have the whole county, you have the whole state. You can share the whole state, all of it, all at once, and make it completely public, right? Or else you can go, no, this particular geotiff tile was bought by this participant or these participants, and I will only provision them in a granular way. You can do both. And the last one is something we don't think about often enough. So it's not only data, it's not only siloed, but because it's siloed, whoever is siloing it has the burden of distributing that data at this network level, right? So you're paying for storage, but for example, if you have a mission to make that data available to the public, you have to pay in some form or another the network egress charge. So you might look at that as your bandwidth charge to whoever's providing your colo service, the servers, for example, the FTP servers, you have to keep up and running, and all the maintenance associated with keeping those things alive, right? And then stuff like when somebody comes along and decides they're going to download everything all at once, what happens to the server? Typically they fall over, or you never scale them to take that kind of load in the first place. Right? So a really big point, and something if you're going to take away one thing, is this idea of in the cloud you can offload the network egress charge. The cloud is a utility pricing model. You pay for cloud resources just like we pay for electricity in this room. You turn it on, you use it, you're paying for it. When we walk out the door, we turn the lights off, we are not paying the utility for electricity, we're not using it, right? And so that applies to compute, storage, and things like network charges all across the board. That's why the cloud works. That's the business model. And so what costs remain? Well, you still have to pay for storage costs, but there's a huge difference here too. Right? Typically, if you're storing something like aerial imagery or LiDAR data, there's a whole bunch of upfront planning associated with the resources required to do that. And typically, people end up overbuying. Right? You're not quite sure, so you'll overspec the hardware that's going to host that stuff. And then you're never sure exactly how much data storage requirement you need, so you're going to get 2 times, 3 times as much storage as you might need. Or more typically, you don't get enough and you run out. Right? In the cloud, you only pay for what you actually use because it's just like electricity. So you pay for storage, but it's much more efficient. The storage pricing is much more competitive in the cloud because we have to compete with other vendors. What you don't pay for is network costs. And so this is the last point in my previous slide. Whoever wants to come and get the data pays for the network egress charge because it's a pay-for-use model. We take care of the billing for you on that. Right? So conceptually, you can have all the data in the world. Let's say imagine it's the most precious data in the world, and you've got petabytes of it. You'd love to share it to the world, but you can't because you don't have the resources and you don't have the budget to pay for the network or pay for the resources to be able to show the rest of the planet all this data you have. Right? In the cloud, you can actually do that because you can have whoever is coming to get the data, who really wants the data, who's willing to pay for the data as it goes out the door. So, and then the compute cost, you don't need FTP servers. It's an HTTP process. There's a bunch of tools. I'll show you a couple in a second that allow you not access at the individual geotiff level. It'll allow you access to all, for example, in today's demo, I'm using the Navy data set. It's 48 terabytes. If you look at where I have it stored, you can go home today and get all 48 terabytes. You might not want to do that, but you could if you wanted to. But you would pay for the network egress charge. But I can give you access to that right away because it's the cloud. Right? If it was on my on-prem data center, I'd have to say no, or I could say, well, you can try, but if everybody in the room is trying to get it at the same time, it probably won't work. And then there's no cost to update distributed copies because there is only one authoritative copy, and that's all we need in the world. Because it's an object store, it's shared in the cloud. It can be secured, it can be public, somewhere in between. It's up to you, but there's only one authoritative copy. So going back to the earlier story, we have contractors out there doing great work. They're acquiring all the sensor data. Speaking generically, it could be work in the ocean, right? They're collecting data for customers. They're shipping on hard disks. But for example, if we're doing a state level acquisition, typically it's shipped, for example, at the county level. And right there, we have things like overlap tiles at the county borders, right? We have data redundancy just in that flow, right? We have tiles that overlap each other at the county level, right? Why do we do that? We don't need to do that. We need to share that tile across our systems. So there's redundancy all over the place. So here I have. I'm sorry, it's a little bit small. And this is the fundamental architecture. It's very simple. The gray area here you see right here is what we call an Amazon Web Services account. And this is a paradigm that exists for whatever cloud vendor we're talking about. You have an account, and because you have that account, you can deploy stuff in the cloud. The cloud, at least in our case, means you have global access to, I can't remember the number, I think 24, 26 different data centers across the globe right now. Every one of you can go home today because you might probably have an Amazon.com login, right? And we know your credit card. Within just a few minutes, you can get an Amazon Web Services account, and you have default access to 20 servers, or whatever horsepower you want, and you can provision yourself 20 terabytes of storage on our UBS system, and you have immediate access to all the core parts that I'm showing you today. That's just the norm, right? So you can basically go home, use your credit card, and fire up your data center any old time you want. And I would suggest you do that, of course, because I work for Amazon Web Services. But what I typically suggest to people is, are you backing up the JPEG images you're taking from that smartphone? Are you in full control? You might want to consider using the same infrastructure that Dropbox and Netflix uses to back up your photos right to our object store. You can play with that and then kind of see how that works. So getting back to this picture, here's an account, and here's what we call an S3 bucket. Bucket is just the name for a top-level container. Every account can have 100 buckets. It's a global namespace. You can do things like put your website in the bucket and show and do HTTP, just do a static website. So here we have, imagine we have a whole bunch of geotiffs or LAS files, whatever you want. And typically in a siloed situation, it gets siloed in this gray zone, right, in this gray box. And it goes out the door up here somewhere. And for the data that lives in traditional storage down here, it has to pass through a gauntlet of services, right? So even if it's the simplest case, it's just an FTP server, you got to fire up some box, you got to install some software, you have to have somebody keeping an eye on this thing, and it will only work to some level of performance, right? Whatever you decide to provision it to. In this world here, if you store data in an object store, you can allow other players in different accounts. So over here I have agency A, agency B. They live in completely different firewall containers. They're different accounts. You can give them access to your object store at the infrastructure level. And that means that they can do things like fire up a cluster of computers over here, a bunch of virtual machines that they just turned on just now, and do, for example, image transforms at whatever scale they want to do. So let's say the contractor provided a bunch of 4-band imagery, and you didn't like that. You wanted 3-band. You could fire up a bunch of machines in the other account that you are paying for. As long as you can see this bucket, you can derive the RGB imagery on your own at whatever scale and speed you want. And then, having done that, pump that into your own bucket. And then make a decision from there whether or not you want to share it to the world or to share it to different agencies. This is all stuff that, would it be impossible to do on-prem? But from an economic perspective, it might be very difficult, right? If only because you don't have access to, 100 nodes for the next hour. And having run that batch operation, you can't throw those servers away. In the cloud, you can do that. So what I want you to do is think in terms of URLs, right? We all do this every day. We do our banking on the web now. We know about HTTPS, right? Secure interfaces, encryption, right? But we're actually still very early days about how we store things like GeoTIFFs and LastFiles. So all it really is think in terms of the TIFF file is not behind a file system. The TIFF file is just an HTTP endpoint that anybody potentially on the planet can get access to just because they have a web browser, right? That's the world we live in. So there's nothing new here. So I will speak mainly about object storage. On Amazon Web Services, it's called Simple Storage Service, S3. It's one of our first 3 services. So when I was working here in Green Bay, small startup, we had one person in Spain, one person in France, 2 guys writing code. We had a GIS, Esri guru who happened to live in Tokyo. I was here in Wisconsin. We have some folks in Iowa. It was a virtual office, right? And all there was EC2 virtual machines on Amazon Web Services called EC2. There was Simple Storage Service. And there was only one other part. It was SQS, a massively scalable queuing system. And that was all we needed to get significant startup finance to do a geoservices startup. Now, Amazon Web Services has over 40 services. All kinds of stuff that I would have a hard time explaining to you, right? Because I can barely keep up. Right? I live and work there, but I can barely keep up. Today, I just want you to concentrate on one of our first 3, which is our object store. That everybody in this room right now that has a smartphone, by the way, probably interacts with every day. You just don't know it, right? If you're a Dropbox user, you interact with this, right? Under the hood, Dropbox uses S3, big customer of ours. If you watch Netflix video, you use S3 indirectly, right? That's where all that Hollywood stuff lives. The interesting thing here is you can go and get yourself an account, or the county can get itself an account. You have access to the same infrastructure that runs the largest companies right now. It's very democratic, right? You have access to all 40 servers. You don't have to use any of them. You could use 3 out of 40, right? But they're all immediately available. And that I'm talking about Amazon right now, but that's fundamentally the same. Whether we're talking Azure or Google or other large players. So S3's been around since 2006. I was one of the early adopters in 2007. Back then, we had about 500 million objects in S3. Even back in 2008, I think we had about 500 million objects, mostly tiled cache data, mostly NAPE data, actually. So it's been around a long time. I will show you a vendor supply tool today. There's many open source tools, very many ways to get and use this service, very mature. Today, I will speak about a less known feature of S3 called requester pays. And this is just what is a bucket level feature. It allows you to put stuff in a bucket, mark it requester pays, and thus have whoever accessed the data pay for the data egress charge. So this feature has been around since the beginning of S3, but not a lot of people know about it. S3 has a lot of different features. It has versioning. You can use it for your front-end website, et cetera, et cetera. It has lifecycle policy. It's a client to our cold storage Glacier, et cetera. The list goes on and on. I won't bore you with that today. But the one thing I'd love for you to keep in mind is that this little checkbox, which is a bucket level policy that you check off, and you can allow, for example, other agencies, other customers, other consortium partners access to your bucket. And it's not your problem, it's our problem to make sure that works, right? It's not your SLA, it's our SLA to make sure that whoever accesses that bucket gets web scale access to it, whether they're running one server against it or 100 server or 10,000 servers. It becomes an infrastructure provider's problem to make that happen for you. So today I'll show you, I'm sure I'm using up too much time here, but the point is there's many views of the same data, right? So I'll be showing geotips today, but people want to look at and use geotips very, very, a bunch of different ways, right? Using different tools, tool stacks, they're doing different kinds of processing, different, many use cases, and I will be showing you just a couple of those today. So, enough slides, demo, and it'll take me a second to get this working. So I'm going to my local disk. I got to fire something up that fell over a little while ago. I'm running Jetty locally. This is all open source stuff that I'm running here. I'm starting a server. This local. This is my notebook's my little development kit here. And once this gets fired up, I should be able to open it. Take a second. I need to call out map server GDAL. Open source project's been around for many, many years. This would also work on, for example, GeoServer. You could also use Esri ArcGIS server on the back end if you wanted to. It's flexible that way. It's up to you. Okay, so I'm in my browser. I just fired up another open source project called Leaflet. I'm looking at one of my customers' data. We're looking at the city of Oakland's 25 centimeter data. This is, I think it's a Lady Community College. Apparently they're called the Eagles. And so we've all seen this before. This is just base layer imagery, right?
Mark, not objective.
Oh, whoops, sorry. How'd that happen? Okay. Thank you for letting me know. There we go. Okay, let me start that again. So here we go, browser. I'm running Leaflet. There's a number of open source projects I can show you. Leaflet is very simple. And this is not an application. It's just the browser running some background imagery, right? So we typically would consider the satellite or aerial image background that we'd see in Google Maps or Azure. So I'm backing off. You see tiles coming in. Some of this stuff is just in the browser cache. And so here is some city level. Here I'm looking at the NAPE data. You can see the lines for where the 25 centimeter data is. And so, there's nothing new here, right? And what's interesting is that this data, and I'm gonna have to fire up another client. So just now we're looking at image data via the browser. We do this kind of thing every day, right, on our phones and on our desktops. Now I'm firing up a vendor supplied tool. So this is, I think it's like $39 for the professional version. This is an S3 object client tool, right? Nice little tool. Makes it easy for folks to kind of play with and understand the object store. Here, you'll see that on the right-hand side, I have a number of accounts. Here I have, this is not my account, it's our public data account. We have a public data program, there's an account, and in that account there's a bunch of buckets, and there's stuff like genome data from universities, and Alzheimer's research data, microbiome data, all kinds of cool scientific data. Up here, there's something called AWS NAPE. This is the bucket that I created, and I pumped a bunch of data in here. The flow here is 24 2 terabyte serial ATA disks from the USDA FPO office, delivered to one of our customers. I helped them ingest it. We have a service that's built for that. Basically, the service will get, you can send them tape, you can send them NAS drives, you can send them bare hard disks, and they will put it into your bucket, right? And so we did that with the hard disk coming from the USDA. I did a little rearranging, but you can see it right here. Here are the states, right? So down here somewhere, because it's W, would be Wisconsin. And here's the 2013 data. And if you drill down, it's 1 meter. I think I added this. So it'd be obvious. Under the 1 meter is the 4-band data, RGB IR. And then these are, I think, FIPS codes. And there's the original set, right? So this is the data provided by the prime contractor that won this federal contract for the state of Wisconsin. The point here is, if you look at this bucket name, this bucket, I'm going to go back up to the top, right there, hit properties. You'll see that there's something called requester pays. It's turned on. That's all it takes, right? Very simple. I can turn it off. Oops, probably don't want to do that because people are using this. Keep that on. And then if you go back to these objects, I'll just do Alabama here, same kind of deal. And if I make this object readable by whoever is authenticated, I now have published this data to whoever wants access to it. Right? And so any one of you can go home, fire up an account, use the free version of Cloudberry, what's it called, the S3 Explorer tool, right? And if you just remember AWS-NATE, you can get access to 48 terabytes of data. You do not have to ask the USDA for 24 2 terabyte disks and pay them roughly $4,500 for it and wait for a few weeks. You have it now. Right? And so the reason I'm showing you this is because if we go back to Leaflet, right, you'll see that this is NATE data. Now, if I tiled all of this content down to level 17, it's just under, I think, 200 million tiles for CONUS, right? It's a lot of tiles, right? Nobody wants to do all that tile, right? And so what I'm showing you is an architecture that leverages a small number of services available to you in the cloud, right? That allows you visibility to all of the US or all of the globe if you have the data, because there's no end to the S3 bucket, right? That allows you to build something that looks a heck of a lot like Google Maps or Azure, but on your budget, right? Within your budget. And so the demo here is, you can see that if I change the layer, I'm going to go to NATE data. So this is the same data via CloudFront, which is our content distribution network. We have over 50 different node locations. This is like Akamai, but it's a self-service Akamai. It allows you, it gets the content closer to Green Bay, for example, right? This CloudFront service, one of our services, is actually looking to S3 for the content. So if I click over here, the data's already here, right? That's where the data sits. But I didn't tile all this stuff already, because that's, that'd be onerous. That's 200 million tiles. I don't want to spend those resources. So if we move this thing around, and this is somewhere in Oakland, right? You'll see that it'll go and look for the content in the object store. If it's not there, it's doing what's called a 303 error. Right? It's not there. The object store can be set up to do a redirect. So when there's no data in the object store is smart enough to go, okay, I need to do a redirect over here. And the redirect is to this thing called tiler environment. Here's an application. This is about a page and a half of code that I wrote that's running under this service here. Here's Tiler. Tiler is very simple. And you can see what it does just by coming back here. Whoops. Confusing myself. Okay. Coming back here. And I've got the Tiler application here. What does Tiler do? Open a new tab and see what Tiler does. Well, it creates tiles, right? It serves up the tile. It wants to satisfy this browser request. But if you chop off this part, which is the TMS request, it'll go into debug mode. Hopefully this will work, and I'll kind of show you what's going on, right? And what Tyler is doing under the hood is just making a WMS request to this thing. So you can see the result of the WMS request here. Let's see, view image. So there's the WMS request, right? So this could be served up by ArcGIS Server, GeoServer, Map Server, a bunch of other stuff, open source stuff, vendor supplied tool stacks, whatever you want. And this is just another service that's underlying the Leaflet stack, right? This service will make a tile on demand if that tile doesn't pre-exist. And what I want you to see here is, now I'm going to go to where that service lives. And you can see here, so I've switched modes now. Now I am in this thing called the Management Interface to Amazon Web Services. So all the vendors have something like this out there. This allows me to do things like create and destroy server instances anytime I want, create and destroy storage anytime I want, pay for it only while I'm using it. You'll see here, when I go into instances and I filter this, because I've got a bunch of things here, to running, I've got a number of machines running. I have a map server, I have the tilers here. There's actually a couple of map servers here. And down here, there's something called auto scaling groups. This is the fundamental. This is the fundamental trick, right? You can create images, and you can have the infrastructure basically create and destroy how many servers you have in real time, right? As a function of load. Right? So you can create something called an auto scaling group. You can see that I have one called map servers, similar names, so I don't get confused, right? And in here, I have it set up max 10, min 20, desired 20, right? And if I go into edit, and if I do something like, give me 10, right? And these are significant machines. These have, I think these are 8 cores with SSDs attached to them, etc. And I just changed that number, the desired state number. And over here, if I can find it, my screen's a little bit small, there's a save button. And what happens is that the infrastructure will automatically note that change. And then when we come back here, within a few minutes, it'll just spin up more WMS horsepower, right? So this I'm doing it manually now, but obviously it could be completely automatic as a function of CPU load, queue depth, whatever metric you want to apply, right? I'm doing it manually. And then if we get rid of this, you see I have a bunch of them pending state. I just turned those servers on, right? And so from the customer experience perspective, so going back to, where we go, to this guy here, open data, so that, we're back to Leaflet. You'll notice that as I move this, these tiles are being created, right? And right now, there's, I think, just 2 servers doing this. So it's not that fast. But if you have a scale problem, you're going to have 10,000 customers coming all of a sudden to look at this. You just need to do what I did, or have it configured so that it will do it automatically for you in the middle of the night so that you don't get woken up. Right? That's all that is available to you. So you can see the opportunities here if you need to do things like batch processing. While you're sitting there, you can fire up 10 servers and do some batch processing, turn it off, and walk away. All this code, it's all open source. There's only like a page or so of code that I wrote is available to anybody in the room who is interested. And I can also do things, because it's a completely shareable paradigm, right? I can do things like go into EC2, and you'll see that here I have these virtual machine images. And so one of these virtual machine images is running this stack, and it's just running some open source code. And so if somebody wants it, it's just a matter of me going, okay, you can have access to my virtual machine. Once you have access to my virtual machine, you can spin up exactly the same stack, right? And then make it your own, because you probably want to tweak it a little bit somehow, right? And then the other thing, how am I doing on time here? Am I way over?
No, yeah, it's
okay. Sorry, I completely lose sense of time. So the other thing I wanted to show you is, so these are instances that are running. I have too many of them running now. I should turn the lights off. Remember to turn the lights off when I'm finished with the demo, right? That's all it takes, though. And then, so you can see I've got a number of machines running. Here's one called Map Server. This is not necessarily following best practice, but here you can see that here is an automatically assigned DNS name, right? So as a public IP, I'm copying that. I'm firing up PuTTY, and I can just map this DNS name in here. So this is a Linux, it's an Ubuntu server. So I need to type in Ubuntu here. But what I wanted to show you is, so I'm on my notebook here, doesn't matter where I am. I have just remoted. So if this is a Windows instance, it'd be a remote desktop login that I do. This is a Linux, I'm just SSH into it, either or, right? But I could be anywhere on the planet, and I have access, low-level access, sysadmin, admin level access to this machine. I have access. I'm looking at it now. It's running somewhere in Virginia. And if I do something like a DFH, you can kind of expose the internals, right? So you can see I have something odd down here at the bottom called YS3FS. So I'm calling out an open source stack called YAS3FS. Don't ask me what that stands for. I think it's the person's the beginning of their last name. I'm not sure. But what I wanted to show you is when I do data name, we see all the states. Now, this is just one machine that I'm looking at. I just fired up, I think, 10 of them, right? Or 9 more. Every one of the machines that I fired up can do the same thing. They all think they have 48 terabytes of data attached to them. They don't, but they have them mounted. And so what's going on is, as I travel around the planet, or the US, so I'll show you how this works. So it's a large area. This country is very large. Getting on an airplane, flying places is no joke. I'm using OpenStreetMap tiles now from MapQuest. I'm backing up. Here's a bigger, wider view of the US. I'm just going to somewhere random now. I haven't been to Kentucky recently. I haven't tiled any of this stuff. I need to zoom in a little bit because I don't have it optimized. I don't have the satellite layers in here. I just have the kind of the high resolution stuff ready to go. Right? Okay. And what I want you to see is that if I go and turn on NAPE, one of these NAPE layers, it won't show up right away because it hasn't built it yet. But that's how quickly it'll build it for me. Right? And so this is the first request that's being pretty close to real-time process, satisfied, because I got a bunch of hardware behind us now. If somebody comes next, they are satisfied by our object store, because a copy is already in our object store, if not in our content distribution network, right? And so the first one will take a second, but everybody else who comes and looks at this data will be immediately satisfied. And that's because the cache layer doesn't live at the server level. The cache layer lives at the web service level or the cloud level. In fact, it lives potentially across the globe right now, and I didn't have to write any code to make that happen, right? I'm just using existing services. And that's the I got, 5 minutes left, right? So I'll kind of finish it off. If anybody wants to talk more about this, kind of the basic architectural components, if anybody wants to see get access to the virtual machine or a little bit of code that I have to do this, I'm happy to do so. The bucket called AWS-NAPE is in our public account bucket, but it's a test bucket at this point, right? We're having some interesting conversations with the owner of this bucket and people involved in this kind of work, like large insurance companies, states that routinely have to do all the heavy lifting around getting the data that don't want to do it anymore, right? Don't want to do hard disks anymore. I'm hoping that eventually that will not be in the Amazon Web Services public account bucket, but it will be, the best case would be in the USDA's bucket, and they take care of it, right? And the fundamental difference is they are not taking care of, for example, some clip and ship environment that gives you access to the geotiffs at scale. So we're talking like 218,000 geotiffs for one set, right? But they're just giving you direct bulk access to the underlying storage infrastructure. And so you can do things quite literally like this, what we're looking at. You can fire up some browser, you go eyeball it, look at it, download it to your machine if you want to. But better would be to fire up virtual machines that are sitting right next to it in the cloud to facilitate the kind of thing that I showed you. And so, the technical demo is that it's relatively simple. It's easy to do, even for all of CONUS, right? It's surely something we can do at the state level. And hopefully save a few pennies, if not more. So, thank you very much. I'll finish it there. So, thank you.